Welcome back to Orgo Lab Scrapbook. In this video, I'll be using the first 7 steps of a procedure taken from LibreText to synthesize crude aspirin, which is also known as acetylsalicylic acid. This experiment procedure was created by James Chicos, David Guerin, and Valerian de Souza from the chemistry department at University of Missouri St. Louis. This synthesis involves using salicylic acid and acetic anhydride with sulfuric acid as a catalyst. Acetic anhydride is a molecule with an ester group and a ketone group, and in this reaction, the ester group replaces the alcohol group in salicylic acid, leaving aspirin and acetic acid as a product. Here's all the products I'll be using. The procedure calls for 2.0 or 0.015 moles of salicylic acid in a 125 milliliter flask, and to that I add 5 milliliters or 0.05 moles of acetic anhydride, followed by 5 drops of concentrated H2SO4 or sulfuric acid. Now, this needs to be heated over a steam bath, which I've set up by putting some water in a beaker and turning up the heating mantle about 200 degrees Celsius, just to make sure that it heats up fast and continues to vigorously boil. The procedure says to only have the flask over the steam bath for 10 minutes, so it doesn't need to run that long. Once I add the sulfuric acid, I need to stir the flask for a little bit, and then I can leave it to react. After the 10 minutes is up, I leave the flask to cool to room temperature and the acetylsalicylic acid begins to crystallize. Once at room temp, I leave this flask in an ice bath to continue to cool down and crystallize. My product is now formed into full crystals. To filter out any acetic acid, I add 50 milliliters of water and then leave the flask once more in an ice bath. I'm about to perform vacuum filtration to separate the solid from the water, and I'll explain how this works. Vacuum filtration is a process that allows liquids and solids to be separated more effectively than gravity filtration, using a vacuum pump and 2 filtration flasks, which have a side attachment where a vacuum tube can attach. One is connected directly to the vacuum pump, and the other, which is our receiving flask, connects to the flask that is connected to the vacuum pump. The final part of the setup for vacuum filtration is the funnel where the liquid and the solid are separated. The funnel I have here is known as a Buchner funnel, and its wide opening allows me to pour large volumes of liquid and solid inside at a time. Once I turn the vacuum pump on, I can pour my flask with my crude aspirin and water into the funnel, and it will suck the water into the receiving flask, leaving just my solid. The final step in our procedure calls to wash the crystals with cold water, which is several portions of 5 milliliters of cold water, and allow the crystals to air dry on the funnel. Once there appears to be no more solvent, take the crystals out. Now that the synthesis is complete, I'm going to let this dry overnight and then weigh the crude product. After drying out the aspirin and placing it in a pre-weighed vial, I found the total weight of my product to be 2.246 grams. And even though we started out with only 2 grams of aspirin, this is entirely possible and is actually a decent amount of product. The concept of percent yield will help us to understand this better. Percent yield is defined as our experimental or actual yield in grams divided by a theoretical yield in grams, and then that number is multiplied by 100 to get it as a percent value. Now, our theoretical yield essentially uses the starting amount of moles to calculate how much product we could get out of this procedure. Our 2 reagents, salicylic acid and acetic anhydride, started out with 0.015 moles and 0.05 moles respectively. The salicylic acid started out with less moles, so thus, this is our limiting reagent, meaning that if all of our salicylic acid reacts, we will have a maximum of 0.015 moles of acetylsalicylic acid. Using the molar mass of acetylsalicylic acid, which is 180.16 grams, we find that we can have a maximum of 2.70 grams. This weight does not account for any impurities or water, so our percent yield may be skewed because of such additives. Using our 2 yields, our percent yield comes out to 83.185%. Again, this could be purely aspirin, but I highly doubt it. Some water or impurities may be present in the crude aspirin. This is where the rest of the procedure comes in. If you follow the link in the description, you can see the rest of the procedure and see how the aspirin can further be purified through multiple different processes. Maybe try it for yourself.